All right, good morning. So 9 a.m. and a lot of people are already awake, that's good. Cool, so just show of hands, who's not using C++11 or at least knows about C++11 already? Okay. You know about C++11, all right. Cool, so pretty much everybody knows at least C++11. That's good because otherwise you would have a hard time, I guess. Cool. So my name is Roland Bock. I'm a principal software engineer at PPRO Financial Limited. I'm also the author of this library here, SQL++11. And this library is going to be the vehicle of this talk. The use case examples of C++17 are based on this library. Right? In order to get you acquainted with the library, I'll give you a short bit of history. So when I started to write C++, that was about 2008. The first thing that I had to do basically was interacting with databases. And at that time, that meant writing strings and sending those strings to the database. And it could look like this. Maybe, hopefully not exactly like this. When I prepared the slides, I deliberately added 3 errors in here. Okay. Anybody sees more than 3, just out of curiosity? Yes. Yes. Not more than 3. All right. Okay. I think there are 5 in there. I'm not sure. So when I gave a test presentation of this talk, I was pointed out to another one. When I went through the slides yesterday evening, I saw another one, I think. So just about the point why this is bad to have such a string-based library. So yeah, there's a space missing after the name. There should be quotes. You shouldn't use equal because that's C++ syntax, that's not SQL. You should probably escape the whole thing, the name thingy, probably, because otherwise you might have SQL injection. And there is a typo. Priority is not spelled that way. So it's just a stupid collection of stuff that happens when you write SQL and C++ on a string-based library. At least it happens to me all the time because I really cannot concentrate on this kind of nonsense. Right? I want the compiler to take care of this. So then in 2010, I had a first RFC for the Boost mailing list. So well, that was still C++ 98, and I said, well, I have this idea of an SQL library, right? What do you think of that? And the Boost community, well, they replied with, yes, there is interest, but also with, well, you shouldn't use vector, damn it, you should use ranges. You should use proto for your DSL, because proto, that is the thing. That was the thing at the time, definitely. Dave Abraham said, I don't like SQL. I cannot program in SQL. Write an algebra library and then make it such that you can transform it to SQL, right? And others said, well, no, that's not the way to do it. I don't want to learn a new language. I'm pretty comfortable with SQL, so keep it this way. Okay, so something was wrong, obviously, and it took me a bit of time. And when C++11 came out, I worked on a new thing. And then 3 years later, presented what I call SQL++11. And this has now a nice interface, I'd say. So you can write code in C++ that pretty much looks like SQL. So anybody who knows SQL can read this. So here we select 2 columns from a table foo with some condition. And then the result rows have members that have appropriate names and appropriate types. Everything is cool, right? And this time the discussion was completely different. This time it was, all right, well, you could still use metaparse because metaparse was then the thing of the day. And you should be parsing strings and turn those into your expressions. Right, not in my life, but okay. And otherwise it was, well, what do you do with prepare statements? How do you handle, I don't know, binary transfer, multi-row inserts? And the people asking, how can I write a connector to my database? So somebody wanted to use Postgres, and I only had connectors to other libraries, other databases. So discussion was completely different, and seems like I hit a nerve there. So in the following years, I gave a bunch of talks about the library, and for instance, a talk about how to reduce the amount of error messages that you get from such a library, because it's heavily templated, and you, as a user if you're a user of heavy templated libraries, then in many cases you get these horrible error messages, and I try to cut those down. So that was one talk. And then last year I gave a talk, pretty ad hoc, about variants of veridic AND. So the task is, if you have a bunch of bools at compile time and you want to figure out if all of them are true, how do you do that? And there are two answers to that. One is for CppCon. That is, you write a small helper that takes a bunch of bools, and then you instantiate this helper in the first time with bool and all these arguments, and in the second time with all the arguments and bool at the end. And if and only if all the arguments are true, then these two helpers are the same, okay, and then still the same returns you the result. Okay, that is, as far as I know, still the fastest way to do it. But there is a much more elegant way to do it, right? And that is with C++17. So there you have fold expressions, and then you can just say, well, I use true as an initial value, and then combine it with AND with every single of the arguments, right? And if the expression is still true, then every argument is true. Okay. If you compare that, well, I'm always going for readability here, even if it's slower to compile. Cool, and that's this talk basically spawned the idea. Okay, I want to migrate SQL++11 to C++17. A bunch of the things that I learned about on my way are presented now in this talk. Right. So, first topic, we'll start off with a bunch of language topics, and then afterwards with a few library topics. First is inline variables and auto non-type template parameters. So, in SQL++11, we have to deal with names somehow. I showed you the example, and also for the generated code for the SQL, you have to deal with names a bit. So there is a necessity to have the SQL name of a column somewhere, for instance, or of a table. These are currently encoded in these static const expr character literals. And there's a problem with those, because you cannot use them at runtime. That is very annoying, right? So they don't count as initialized for the linker. You can use them at compile time for crazy stuff, but you cannot use them at runtime. So I had to work around that. Also, I wanted to have something that I can use to make sure that all these names are unique. We'll come to that. And the idea was to wrap these into something like this, a character sequence that just takes a bunch of characters as template arguments. And then, well, if you want to have the string representation, well, you can just ask for a character pointer that contains these characters. Seems stupid, but in C++11 you had to do it this way. Now, how do you construct that? As I said, you can use the character sequence at compile time. So what you can do is you can pass this character sequence as a reference to a template. You also have to pass the length, because otherwise the template wouldn't know what to do with it. And then you can, from there, build a character sequence. Okay, so using the index sequence, and then you can specialize on that and just iterate through all of those and put that into the character sequence type. Okay. By the way, if you have questions, feel free to ask them, or otherwise just wait and go to the microphone later. Yes.
You can wrap a character arrays into a function, a static function, and get rid of the problem of the link by making them static to the function.
Yeah. Also, the comment is I could have made the instead of using a member directly, I could have a static function of this type that returns this. But then again, I still need to create this type for other purposes. Okay, and it's more code, and these things are exposed to the user. So I don't want to have an additional function in there. I want to have it as short as possible. So cool. So in the end, I had something like this. So this character literal, and then a using for this type. Now in CppCon, the situation has changed because, well, at least this compiles. So if you want to do just that, to have a string that you can define a compile time and use at runtime, that's cool. This works now because we have inline variables, and these are defined in place just like that. So it does what you expect to do. There's no surprise at link time. And static const_expr variables are by definition always inline. Okay, so that is neat. Reduces the boilerplate for this character sequence class a bit. And what we also can do is we can now pass variables or references or whatever, so any non-type template parameters to the template without specifying the type. This is neat in the sense that I don't have to pass the length anymore to this template. So this make character sequence now just gets the character array and well, we'll do something with it. Behind the scenes, it does still the same thing. So you have a character sequence impl that is specialized then for a character array of a given length. You don't get around that, but then, well, after that, the same machinery continues to work. But if you compare this code, in the first case, you had to pass the length. So this is duplication. Feels stupid that you have to pass the size of the literal and the literal itself. In CppCon, you get rid of that. Right? That's gone. It's easier to read. Good. Another interesting side effect of CppCon being simpler is that, well, if you don't have to fight to get this to work at all, you can concentrate more on the beauty of the thing. Right? So I had more time on my hands to think about it, and, well, things that should have been obvious probably in the first place, but I just didn't have the time to think about them, was I can make this character sequence generation an external function, basically. So in template metaprogramming terms, an external function. It's a free function of the struct. I don't have to have that inside of the struct. There's no value of having the character sequence type inside of the struct. Okay. So in the end, I just have that. Okay. I find this way more beautiful than what I had before. And that's thanks to CppCon. Right. So yeah, nicer code, I think. It's less code. It's improved compile times because I have, in the end, less types, because before those they were embedded types sometimes, or tab aliases at least. All right, moving on to the next thing. Any questions, by the way, for this here? Okay, cool. So the next part is about no discard, if const_expr, and class template deduction. And let's start with with a motivating example for this. So in sql11, most of the things that you can do wrong are known to the compiler, and the compiler will tell you about it. So whenever you forget some column, a table in the front where you have columns selected, the compiler will tell you. If you're comparing apples and oranges, the compiler will tell you. If you have columns with identical names, the compiler will tell you. But still, you can do a few things incorrectly. Like here, you select all the columns from T with some condition, and then store that into some variable. And then later on, after some other code maybe, you say, oh, right, I want to order them. Right? And you say s order by something. Now, this looks reasonable, but it does basically nothing. The thing is that when you call order by, that is a const member function of the select. It just returns a new statement that then contains the order by. So calling this, while it does something and returns something, but in the end, everything be erased and result in nothing, and especially S will not be changed. So your SQL results will probably be unexpected. Right. So, yes, Jason.
Well, I'm maybe jumping ahead, but I'm curious if you just found in general. Well, okay, no, go to the next slide, then I'll ask my question.
Okay.
I am jumping ahead. I'll ask a question.
All right, cool. I think you will have to wait for a couple of more slides,
okay,
but all right. Cool. So before we look at everything that has changed, let's first see how it's currently implemented in C++11. So you have this order by function. It's a member function of a clause, which is then the base class of a statement. The member function takes a bunch of expressions, right? And then it has a return type that depends on this check order by thingy that basically returns whether the expressions are reasonable for order by or not. And this new statement thingy is a local type alias, and it will do some stuff depending on this condition, and we'll use this order by to with the expressions to construct a new statement, basically. Okay. The details of that are not really important right now. And then it will do tag dispatch inside of this function to the implementation of order by. Yes?
Just to understand, is the idea here that if order by is not valid, this will spin away?
No, it will not spin away. You'll see just in a second in the overloads that something else is happening. So the order by impl will then be called with tag dispatch. So depending on what check order by, what kind of type that is. There is a good case. In that case, check order by will be of consistent type. That will just create a new statement with the new order by, and everything is fine. And then in the bad case, so everything that is not consistent will return a special error indicating type. If you've seen one of my previous talks, this thing will internally contain a static assert, which will fire under normal circumstances. But if you want to test it, you can test that whether the user will actually get the static assert that the user should get. Right. All right. So, is that nice? Is that easy to read? I don't know. I really don't like it, to be honest. It works just fine, but there should be better ways. And if we go to C++17, well, we can get rid of all the horrible tag dispatch. So in C++17, we have, of course, all the features of C++14 as well. In particular, we have return type deduction. But we also have this new feature that is called if const expert. And now we use basically the same check as before, which you can evaluate to true or false. And you put that into the if const expert. And then in the good case, well, we basically do the same as before. We return a new statement. In the bad case, we return something else, right? That looks funny, but it works. Why does it work? Well, because if const expert means that one of the blocks in the if statement, so either the good case or the bad case, will be actually compiled, and the other one is pretty much ignored. Has to be syntactically correct. The compiler will check that for you, so you cannot write complete garbage in there. But otherwise, the compiler will ignore it. Right? So for return type deduction, either of the branches is gone away, which is why we can seemingly return two different return types from this function. Right? So that, I think, is pretty neat. So we get rid of the complete nonsense of tag dispatch. It's much more readable. And if you compare that to the previous slide, by the way, this does not contain the implementations of the functions, right? This is just the boilerplate, right? It's much more characters. If you go here, way more white space, and it includes actually the implementation of the functions, right? I mean, they're not very long, admittedly, but still. Right? So this is wonderful. This is life-changing for anyone who's using tag dispatch these days. Yo.
Why do you decay
Because it's const, and I have specializations for those which are specialized on non-const. Oh, sorry. The question was, why do I decay the check type? Yes, Ben.
I don't know the answer to this. Is it possible to put the check initialization in the if concept representation?
Yes. Yes, you can. So with CppCon, you can move the initialization of the check into the if you want that. So
I like that.
yeah. So it's even shorter now. It doesn't pollute the outer scope, right? So well, that is also cool. All right, moving on. Then we have these things here, these proxy functions, make tuple. Now, make tuple does some additional magic that you may want to rely on. So what I'm saying now is not for every use case. So for instance, make tuple also, I think, resolves standard reference. But what you also can do is, instead of writing this, what you would have done in CppCon, you can now use the constructor guides for class template deduction, and just write this. Because what did work in the past with normal functions, the compiler can deduce the argument types that you pass it. That didn't work in the past, so up until 2014, CppCon, sorry, this didn't work. But with CppCon, this works just fine. So the compiler can, for many of the standard types, can already deduce that and figure out the template parameters for tuple itself. And we can do the same for our own things, and then the whole questions of whether I want to decay this or not will go away, because I can use template, class template deduction for this as well. In some cases, I have to help the compiler. In many cases, the compiler will just be able to deduce it by the constructors that some class has, But in the case of bad statement, the last one I mentioned before, I have some specialization for those, and the primary template is not even defined, or was not even defined until CppCon 17. So if the primary template doesn't have any constructor, then the compiler won't be able to deduce anything, regardless of what kind of specialization you have and what kind of constructors those have. That doesn't matter. You have to have compiler guides in the primary template or associated with the primary template. So in this case, well, bad statement as the primary template is something that contains a static assert that will this wrong thing will evaluate to false, sorry. And so whenever you try to specialize this or to use this, this will fire a static assert and tell you to use some other specialization. But there is a constructor added to this nonetheless. Right? And this helps the compiler to figure out which bad statement to use. Okay, because it takes an argument of the template parameter type. Cool. So now we have this, and I hope that we're now coming to Jason's question or Jason's remark, what to do with the return types. Because we haven't done anything yet. So far, we have just cleaned it up, made it easier to read. So while all that is cool, we still have the same problem that we could return this and the user would not be any wiser. But there is a new keyword or a new attribute for functions. You can say no discard, and that's an indicator that you don't want anybody to accidentally discard the return value of this function, right? And then if you call this in the same way as we did before, then there's almost certainly a compiler warning. Almost certainly, because the standard doesn't mandate that. I don't know why. It highly recommends it. I don't know the exact wording for that, but it basically says implementers are recommended to issue a warning here, but it's not mandatory. Yes, Jason.
I don't believe there are any mandated warnings in the standard, so that might be why they decided to not add it there. But I was wondering if you found, in general, that adding no discard on all return values of const member functions was like a best practice to do cross-request base. Okay, so the question is whether adding no discard to all const member functions that return something is a good idea. Yeah. Yes, I think so. Okay. Yeah. It sounds like a good idea. I hadn't considered it until you just put this up. Okay. Well, cool. Yeah. I'm using it all over the place. So wherever I return something from a const function, I do that because everything else would probably be a bad usage. Yeah. What is it? Anyway, so yeah. All right. Okay. I think we should. Thank you. Stop the tool discussion here before it derails. All right. Thanks. Okay. So yeah, as I think everybody's seen, so this results in much nicer code, much less code, cleaner code, because, well, you don't have all this additional rubbish that you have to care about with template parameters and decay and whatnot. There is improved compile time because, well, you don't have all these additional template instantiations, and less bugs. Right? Users have less bugs with these. Cool. So moving on, fold expressions. I've shown this example in the beginning. This thing for figuring out whether all the rules are true, that is so simple to write now that it doesn't even make sense to have an alias for that. You can just use it wherever you want. Right? That's just really nice. Okay. Good. One use of fold expressions that I have in the library is print tuple members as comma-separated list. Okay. And for this, I have a small helper that basically does nothing but add a comma to a stream and then return the value. So yeah, you instantiate it with the stream, a separator, and then it will figure out whether it's the first time that it's called, and then it will set its first false, and otherwise it will just print the separator to the stream and return the expression that you handed it in. And that can be used like this in this code here. So I instantiate a separator with OStream in this case and a comma as a separator, and then I can use that in the fold expression, right? So on the left end, I start with OStream and then just left shift or stream every of these expressions into the stream. And before you get too wrinkled up, sorry, this only works in my code because I know for sure that when this function is called with this tuple with these columns here, I know for sure that they're all different types. Otherwise, you would be in deep trouble with this code. I mean, otherwise, you would have to go by index. Right? But that would add another level of indirection, and for the index list, this is nice. Right? Okay. Everything good? You have a question? Okay. Cool. Another thing that I already mentioned that I have is typesets. So I want to compare types and figure out whether, for instance, all of them are unique. So typesets are a neat way to do it. And typesets become much more easy in CppCon. So in order to write a typeset, well, we start with something that can be used as a base class, and then, well, we create some typeset structure. It takes a bunch of types, which are hopefully unique. And internally, it has this struct impl that is then inheriting from all these different base classes. Right? This will crash the compiler if you pass in anything that is not unique, by the way. Well, crashes some compilers, I'd say. And then, before we go into how to construct this, we'll start with checks. Right? How to check whether there's an element in this set. Well, you can just check whether base t is a base class of this impl class, right? And the compiler will just tell you, yeah, well, yes, it is or it isn't, depending on whether t is one of these elements. Okay, so that's fine. And then you can start with fold expressions, for instance, to figure out if something is a superset of something else, right? And in this case, if it's a superset, then for the right-hand side, all these t's have to be elements of ourselves, which is what we test here. So we start with true, and then combine it with and count for first t, second t, and so on. That's what fold expression does, right? Goes through all the arguments one by one and applies this operator to the left. Right? There are different versions of how fold expressions can work, whether left or right, or you can have different ways to initialize them. But I like this best for most cases. Okay, so that is neat. Now we're coming closer now to actually constructing something. So if we want to insert a new type into this typeset, then well, we have a function, and well, no discard because it's a const function. It takes a template parameter t, and then we can just check, well, if the count is false, then we already have it. If the count is true, then we already have it. Then we just return an instance of this typeset, and otherwise we add the t to the list of elements that we already have, and return that. Okay, so we're done. And then to make this useful for fold expressions, you just add an operator that does exactly the same. Right? So this one has to take a value, and since we don't know how, in all cases how to construct a value, this uses the base class or the space helper type. And then it just calls insert and returns that. Okay. And now, if we want to construct a typeset, we just take any number of t's. Right? They don't have to be unique. Just take any number of t's and then initialize the fold expression with an empty typeset and just shift every of our types in there. Right? It will make sure that everything is unique. Okay? And then we have a typeset. Right? And then we can use it like this. That's for the columns. So when you select columns, like we then used in this print example, this will check whether the character sequence types of all these columns, so it's extracting the names from these columns and represents them as types, whether all of these are, puts all of these in a typeset, and then compares the size of this typeset with the number of columns. And if that happens to be the same, then everything is unique. So that's the good case. Good. So yeah, fold expressions lead to more expressive code, lead to less code, lead to improved compile times. So I haven't done extensive tests with this, but for instance, I created I used this create typeset function with what I have in sqlpp11 and what I now have in the 17 version with just 1,000 ints. And well, it's the simplest test that I could come up with in a short time. The speed improvement is factor 4. So that is not just a few percent. Also, since this is so much easier to implement, so much less trouble to do, well, it's not, you don't feel like you have to use it all the time because it was so hard to produce, right? So that's why I say less reduced golden hammer syndrome. You don't use this thing all the time just because you have it. That also leads to better compile times because sets are still expensive. Cool. So yeah, that's what I wanted to present about core features. We now use some library features. Let's see. Okay, enough time. So string view. Just a few words about string view. Currently, when you have a text result field in sqlpp11, you typically have some character pointer that you're provided, or the content of it, which is provided by the backend of the database, and a length. And then when you get the results or get a new result row, you bind this thing to some kind of target, and that will reassign the text pointer and the length, and then you assign these values to a string, right? Because, well, in earlier versions we didn't have a string view. So if the length is always the same, that's not that bad because, well, you basically have to do a bit of memcopy with the assign. But if the size increases, for instance, from row to row, then you will have reallocations in addition. So I don't know, that's annoying. With CppCon, we now have string view. String view is a non-owning view on a character pointer, for instance, and it doesn't allocate anything. It just happens to take a character pointer and a length. That's exactly what we have. We can put this in the string view, and it will then have a representation that almost looks like a string but isn't. Right? It has pretty much the same interface as a string, can be converted to a string. So if the user wants to do something that like storing it into a string, that's fine. There's no difference in usage. But internally, at least, the memory usage and everything is much nicer for this. Okay, so cool feature. Yeah, basically improved runtime performance. The next two things are stud variant and stud optional. And in order to see what I want to do, let's go with this. So all the examples that I've shown before were examples where the structure of the query is completely known at compile time. So every column is known, every table is known, everything. Right? But there are situations where I don't know, you select some data from a database, and sometimes you want to add a new column or a different column because this column is expensive. And you don't want to extract it every time, but based on some condition, you want to extract it, right? So that's where this dynamic select comes into play. You can say, okay, dynamic select, and then you have dynamic columns and dynamic from. You start with whatever is the default, and then I don't know if there is some condition. Then we'll say, all right, I'll add another column, and under some other condition, I'll add another column from even a different table than I used before. In that case, I also add a dynamic join. So I mean that's just wording in the library. Basically, you add a join to the from this way, and then the library will take care of that for you. But since this is done at runtime, you cannot have the same cool return rows or result rows that we had before. So the ID, which is statically added to the query, that is still accessible as a member of the struct. The others, well, they have to be taken now in a map-like fashion in this case. So we'll add a string here into this operator and then hopefully get something out. The type is also not clear. The library currently only returns strings, and then you have to do whatever you want to do with it. So I really don't like that. Then I thought about, well, first about variant, what to do with it. And I thought, well, variant could improve the situation quite a bit, because instead of returning strings all the time, I could return a variant. And there are not too many types that this library would return normally. There's, I don't know, there's bool, and there's some integral types. There's a text type. There's a blob, date time. Okay, that's, I don't know, half a dozen or so. And we could return a variant on all of those, and then the user could figure out at runtime with some checks what kind of type this is, whether this actually matches the expectations. So that would be an option, but we would still do name lookup like this. I don't know. Not a big fan of those, and also this checking at runtime whether the type is really what I expect. Yeah, okay, not so good. And then I thought, well, if I look at use cases, not just the general one where somebody maybe wants to add 1,000 additional columns under certain circumstances. The usual use case is that you have some columns that are expensive. I don't know, maybe 1, maybe 3, I don't know, but a very limited number. So what I could do is I could say, well, I indicate these columns as optional, right? Which is really what I want to express. And the user can say, well, this column is optional, and only if this optional has a value, then that tells the library that it should actually retrieve this value. Okay, and then it would look like this. So same code as before. Under some condition, we say, all right, we pass an optional of foo name. So of this column into the library, into the select call. And otherwise, if the condition is false, then we just pass stud nullopt, which happens to be an argument for the stud optional constructor of any type, and we'll just construct an empty optional. So this way, the user can indicate whether or not they want to have this column selected and returned, right? And in the second case, where we actually have a different table in addition, then well, we can also join and say, well, this table that I join in here, that's optional, and the whole join expression will only be created for the SQL if this optional is not empty. Right. So this is, I think, a reasonable use of optional, much better than the variant version that I had thought of before. And as you can see, well, the good news now is I now have members in my result struct that have the appropriate names. The only thing I have to do in the result is check the condition, and then I'm pretty sure that this will have the well, not pretty sure. There is pretty much a guarantee that that this thing will have some value. Unless the column itself is null, then this might still be an empty optional. Okay, but all this crazy lookup by string, that's gone. All the insecurity, what the type might be, that's gone. So we're back in type safety length. Cool. So even though I didn't use variant in the end, it gave me new ideas of how to do it. Basically led me to the idea of using optional. So yeah, thinking about CppCon features may be helpful, even if you end up not using them. That's a nice thing about this. And that brings me to the summary of what we've seen here. So a bunch of core features of the language, right? Yeah, they're, at least for my use, they're just wonderful, awesome, whatever you want to call it. It's super. And if somebody says that CppCon was a minor release, well, I don't know, not for me. For me, it's a great release. CppCon is just great for these users. Even though I'm variant, I don't use it yet, but other people will certainly have uses for that. Cool. And as mentioned, thinking about these things and experimenting with that also improves my CppCon code, right? Just by not having to think about stuff that hard anymore and coming to more elegant solutions. Some of them suddenly you realize can be translated back to CppCon, right? And then code is easier. So for instance, my typeset in I haven't replaced it yet, but the typeset that I showed in CppCon is not that hard to come up with something that is pretty close in CppCon. It's not that bad, right? But I never had the ideas to do it until I experimented with CppCon. So even if you cannot use it in your professional life or in your library currently, just play with it. It's cool, right? And it helps you. All right. That's it. Thank you. Right, we have a couple of minutes for questions. Yeah, go ahead.
So you showed iteration over the return of your selects with a range 4.
Yes.
Can you use structured bindings to unpack the struct that you got back?
So the question is, can I use structured bindings to deconstruct the result row? I guess so, yes. If not, then I'll try to make it happen for sure. Yeah.
I think the practical problem would be knowing what order they were in the resulting struct so that you could actually decompose them in a meaningful way. Yeah. I'm guessing you don't have any guarantee as to what order the elements are in the return structure.
Okay, so the remark is that I might not have a guarantee of the order of the elements. Actually, I do.
The order of the columns, yeah.
Yeah. So
Okay.
the columns are ordered in the way. Inside of the struct, they are ordered in the same way as you selected them in the function.
Okay.
Yeah. So there is a guarantee for the order, but then again, well, if you have several columns of the same type, structured binding might not exactly be what you want, because then you don't have the name safety anymore. I really like the name safety of the data members.
Where can we find the slides?
The slides will be on GitHub sometime soon. So I guess all speaker slides will be uploaded to GitHub and it will be announced. Right. More questions? All right, then thanks again.